The next problem is phrased in terms of the point 352, is phrased actually in terms of the vector from 352 to xyz. Now, when you see the vector from 352 to xyz, you really want to draw a picture of that vector. And it doesn't have to be accurate in 3 dimensions. You don't know where 352 is, and you certainly don't know where xyz is. So you just mark down 2 points, call one of them 352, call the other xyz, and draw a vector to indicate that. A vector from point to point to indicate the vector that the problem is talking about. Gives you something to look at. Then you're asked to look at the condition that that vector is perpendicular to the vector you found here. Well, the vector we found here was 8k, the cross product of the 2 vectors that we chose connecting to, between 2 pairs of these 3 points. Okay, so that vector is 8k, so we want this vector to be perpendicular to the 8k vector, so we can kind of draw that this way. It looks kind of perpendicular. Okay, now of course we're talking about this vector, so we probably want something in symbols to represent the vector. So we're going to say v equals whatever this vector would be. Well, what is this vector? It goes from this point to this point, so the x component is x minus 3. So we have x minus 3, and the unit vector in the x direction is I, so we have x minus 3i. And then we have y minus 5j and z minus 2k. Okay, well, now the condition is that the condition we're trying to express is that the vector from here to here is perpendicular to the vector we found here. Well, vector v is perpendicular to 8k if and only if the dot product is 0. We're used to that fact. And then we just figure that out. The dot product of this vector with the 8k vector is just, we have no I or j component on this one, so that x minus 3 dotted with 0i is 0. X minus 3 times the 0 that we have for the I component of this vector is 0. This times the 0 vector that we have, or the 0 coefficient of j in this vector is going to give us 0, leaving us just z minus 2 times 8. So that z minus 2 times 8 is 0, and that's simply equivalent to saying that z minus 2 equals 0. There's no point in multiplying through by 8. 8 is not 0. We can divide both sides of the equation by any non-zero quantity, and the equation we end up with is completely equivalent to the original. And of course, that is the equivalent to saying that z equals 2. Okay, so that for any x, y, z point, as long as z equals 2, this vector will lie in the plane perpendicular to the 8k vector. And to say that the z-coordinate has to be 2 without restricting x and y, well, that just puts us in the plane. If the origin is, if the xy plane is down here, the plane z equals 2 is up here, as I hope you're aware of at this point. And if not, think about that. If you're not sure why the z equals 2 point lies, the z equals 2 plane lies 2 units above the xy plane, email me, come and ask me, we'll talk about it. Okay. That is that situation. Now we're going to move on to a couple of others.